Today is the 11th of March 2024, and this will be our third video on trigonometry. Today I just wanted to do a bit of work with Sokatua. Okay, thank you everyone. Okay, I've got one more subscriber. Okay, so we are going forward. We are edging on little by little, drip by drip. Thank you. We are spreading the message. Thank you to all my subscribers. Okay, please share, like, follow, subscribe. Okay, help somebody get the extra help they need. Okay, to whether they have an exam this year or they are planning to go back in education, so that you can make it a bit easier for them, so that if they decide to, then they have the tools they have to do it, so that they won't say that, oh, I didn't get the help. Okay, we have the help here on this platform. So please, and if the account is not yours, ask permission from the subscriber, or just take your phone or your tablet to wherever you are watching us from and say, please, can you help me open an account, and then subscribe, and then it comes straight to you. It gives you a notification when I load video. Okay, I normally write in the comment section. You will always see that, because there is a lot of numbers involved. Okay, so this is 0.25. so if you hear 0.5, go by the nose, please. Okay, I'll appreciate your help on that. Beware of scammers. Okay, this is a warning to all of us. Okay, don't fall for them. There might be duplicate accounts there. They might come to your inbox. They might even send you email. Okay, because at times when you register, they ask you to put certain details online just for verification. But because the scammers are becoming sophisticated, they know how to get into your inbox and find a way of making it look like it is their account. Please, if somebody is asking you for donation for anything under this platform, it's not me. Okay, don't fall for it. Watch last video for recap. We've been doing work on trigonometry. I have come back the intro, giving you all the formulas you will need for this topic, especially the higher student. With the foundation student, they might ask you a few questions here and there on Pythagoras and stuff. Okay, but with the higher student, they might take it a little bit a notch. So I've brought in all the equations. The more you use them, the more you become familiar with them. So start using them now. Okay, you have time between now and your exam dates to get it right. So start using them now. Okay, if you start even watching, don't cram it. just watch it a bit by bit, and whatever you learn, make sure you learn it properly. Okay, because if you learn it properly, then you don't have to know everything, but you can learn certain things like graph work, algebra, fractions, decimals, Pythagoras. These are things you can learn, okay, but your factors, and then and they always come. So immediately it comes, you would be able to answer those questions and get your marks, and at least it can give you the minimum C. Okay, even though you can push a bit higher. Okay, now watch last video for recap. Today our starter is about terminating fractions. We've been doing recurring and terminating fractions. So we said the clue is in the denominator, so they can give you 4 or 5 fractions and then ask you which one terminates or which one recur. Okay, so you might have to look at it. So for instance, 1/4 will terminate because the prime factors are 2. Okay, because 4 is 2 times 2. So if you change 1/4 into a decimal, it's 0.25. Okay, you should know this off your head. Okay, but you can use the long division method to also verify if you don't know that. So you know it's going to terminate, it stops. Okay, you don't get 253, 253, 253. You don't get that. It just stops, or you don't get 2222.2222. It stops at 5. The second one is 2/5. It will also terminate because it has a prime factor of 5. So if the prime factors are 2 or 5, it's going to terminate. 2/5 again is 0.4. Okay, so it terminates. So here you can use the long division method to verify, or as these are simple fractions like half, 1/4, 2/5. Okay, so you should be able to know that. 3/8, here it will also terminate because the prime factors are only 2. Okay, so now if you use the long division method, it's 0.375. Okay, so 0.375. Okay, now today we just want to look at some more examples on trigonometry and using the right angle triangle by the Sokatua ones. Okay, and then tomorrow we'll look at other stuff. Okay, now find x. The angle here is 52 and x is opposite. You know the adjacent length, so you are going to use TOA. So tan of 52 will be opposite, which is your x, divided by 9 centimeters. Unit is in 9, so x should end up being in unit is in centimeters, so x should end up being centimeters. So tan 52 equals x over a. Okay, so x will be 9 tan 52. So 9 times tan 52 on the calculator is 1.2799. So when you multiply, you get 11.5 centimeters. These diagrams today are not to scale, okay, please. So x is in 11.5 centimeters. Try, if you're working with angles, leave your answer to one decimal place, okay? Unless you are told otherwise, leave your answer in one decimal place, okay? Now, length. Here, it was given as a whole number. If you say 12, they might accept it, but 11.5 centimeters to one decimal place, okay, because this is more accurate than 12. Now, the second example, find x. So that is your right angle triangle. The side is here, okay. All these are right angle triangles. I haven't done this thing, but it is right angle triangle. So now we know the opposite, and we know the hypotenuse, and we have an angle. So we are going to use sine, which is the slope. So sine of 42 will be opposite over hypotenuse, okay. My aim is to show you how to use this to solve, use these formulas to solve, okay. If I'm able to do that today, even with the foundation student, I'll be happy, so that if it comes, you'll be able to figure out, because these are easy marks to collect. So sine 42 will be x opposite over hypotenuse. So x will be 15 sine of 42. This might be a calculator paper. So 15 times sine 42 will be 0.6691. I had to cross this out because when I put this in the calculator, I didn't erase it, okay. So it gave me a wrong answer, so I had to redo it again, okay. So I had to recheck, because when I did it, I was like, sine 42 shouldn't be this, okay, because I used to use the 4-figure table, so some of the figures a bit like I have to check and recheck, okay, because the calculator can also give you a wrong answer if it's in the wrong mode. So I realized that, yeah, so 15 times 0.6691 will be 10.0 centimeters. You will only be able to know some of these things if you do continue practicing and practicing, because after a while you realize that, oh, sine 42 shouldn't be giving me this. So if the calculator gave me that, then maybe I didn't put in the right figures, or there is something wrong here, okay. Unlike the 4-figure table, it's printed and it's put in front of you, so that is what it is. But with the calculator, at times, in the wrong mode, you can get the wrong answer. So you have to always make a habit of clearing it before you start a new thing, okay. So I find it a bit of distraction. I'll prefer to do the non-calculator work, than calculator work, okay? Because immediately you get it in the wrong mode, or you, for instance, assuming you accidentally press cos 42 and sine 42 will give you different numbers. So even though you have the calculator, your x answer will be different. So there you will get it wrong. So be careful when you are using your calculator as well. That is why please start using it now. Stop using the calculator on your phone. Okay, I hope you have the calculator that you want to use for your exams if you are going to write an exam soon. Okay, get used to it, get acquainted with it. Okay, now find S again. This is the right angle triangle. The right angle triangle is there. You know opposite and you know adjacent. So here we'll use TOA. Okay, so you see how it is, how I'm applying it. So immediately I see it, I know that also tan of x will be opposite, which is 4.5 divided by 8.3. So tan x, if you divide 8.5 or 4.5 over 8.3, if 4 over 5 is about half. Okay, so that figure 0.5422 is about right. Okay, so tan of x is the tan inverse of 0.5422. So you go on your calculator, you press your second function and then press tan. Okay, and then it will give you 28.5, okay, degrees as in angles. If you are working with angles and you've not been told otherwise, leave your answer to 1 decimal place. Now, our next example, I'm just trying to show you some examples today. Okay, our next example, okay, is a right angle triangle again. Find x. Okay, so now the x is here. We know the adjacent and we know the hypotenuse, so we are going to use CAR, which is the cosine. So the cos of x will be adjacent over the hypotenuse. The adjacent is 25.6, hypotenuse is 30.6. So cos of x will be equal to 0.8366. Again, if you look at the whole number, 26 divided by 30. Okay, if it's 30 divided by 30, if I run it to the nearest whole number, I'll get 1. So 8.366 is about right there. So x will give me cos of inverse of 0.8366. So now you press the second function in your calculator, then it will give you the cos inverse, which is 33.2 degrees. So this angle is 33.2 degrees to 1 decimal place again. Our next example, okay, find x. This is the angle we are looking for. We know the opposite, we know the adjacent. Okay, so we are going to use tan, which is TOA. So opposite 3.1 divided by 4.5 there. So 3.1 divided by 4.5 will give us 0.6889. Okay, now when I do it first hand, I use the four decimal places to get my S figure as accurate as possible. Okay, so x will be equal to tan inverse 0.6889. Now x, if you do the tan inverse of this 4-figure number, comes out on the calculator as 34.6 degrees. 1 decimal place. Okay, so I've brought you some examples today to show you how to apply the SOHCAHTOA. Okay, so if you have opposite and adjacent, you use tan. If you have adjacent and hypotenuse, you use cos. If you have opposite and hypotenuse and an angle, you use sine. Okay, so please go back and look, and in the starter I brought you some terminating fractions. I've showed you how to use the long division. Okay, but they are simple fractions, and if you look at the denominator, they either have prime factors of 2 and of 5. If the prime factors are 2 and 5, or any of 2 or 5, then it will terminate. But if you have prime factors of 3, 7, 11, 17, okay, these prime factors will recur. Okay, so this is what I came to share with you today. Please subscribe, share, like, follow. Okay, spread the message. Thank you very much. Okay, thank you very much for watching my video today, and I'll see you in the next.